Hi everyone. So I hope you have watched my video number 1 and video number 2. So today I'm in this third video I'm going to talk about the various types of elimination reactions, that is E1, E2 and E1CV. So let's begin with beta elimination. Beta elimination is nothing but your 1-2 elimination. So beta eliminations can be further subdivided into 3 categories depending upon the mechanistic pathway. Mechanistic pathway helps us to understand how the product is formed and what are the different activation energy parameters. So the most important aspect is to establish the number of molecules taking part in the elimination step. That is the molecularity of the reaction. That is whether the reaction depends upon single component or whether it depends upon 2 component. So the type of beta eliminations are E2, E1 and E1CV. So we are going to discuss one by one each of these reactions. So these are read as elimination or bimolecular, that is E2, that is elimination unimolecular conjugate base. So this is your E2 and then this is the E1 and this is E1CV. So let's go and discuss about each reaction in detail. So E2 elimination. E2 elimination, as I said, it depends upon 2 different substrates, that is your alkyl halide and then your base. So let's see what is alkyl halide and which base is used in the case of E2 elimination. So 2 groups, as I said, depart simultaneously. That is what we have discussed in our previous videos. So it involves one step, that is the reaction does not involve any intermediate. Bimolecular reaction. Why it is bimolecular? Because there is the presence of substrate and the nucleophile. So this indicates that is the rate of reaction. It depends upon both the substrate and the base that is we are going to use. Okay, so let's see the base abstract. So what it does actually. So we are going to see in detail in the mechanism what the base do and how the elimination occurs. The base abstract the beta hydrogen. So as you have known that the beta hydrogen, so this is our alpha carbon and this is the beta carbon. So beta carbon has 3 protons on the right side and 3 protons on the left side. So these protons are acidic. Why they are acidic? Because of the negative inductive effect of the halogen. As halogen is the electron negative atom, it will pull the electrons. So this will pull the electrons and that's the reason this proton becomes acidic. And because of this acidity of the proton, the base will abstract the proton and we get the elimination product. So let's see the mechanism. So this is my alkyl halide. So this is my alpha carbon and this is my beta carbon. Okay, and I can assign this carbon as a carbon number 1 and this is my carbon number 2. So this is a base. So this base, it can be your any metal alkoxide. So this is alkoxide. It is not general hydroxide base. It is a metal alkoxide. So metal alkoxide, it can be sodium or potassium. So it abstracts the acidic proton and then it undergo elimination. So you can see there is a arrows are moving towards a good leaving group, or we can say towards the leaving group. So we can see this is a transition state. There is no intermediate. So this type of transition states are like we can call these are the concerted. Concerted means the abstraction of the proton and the leaving group occurs simultaneously, and that's the reason we call this a concerted step, and that's the reason there is no intermediate, and this is a transition state, that is a partial double bond and partial single bond between the carbon hydrogen and carbon halogen. So let's see what is the product, and this is the product, that is our alkene. So alkene is the ultimate product that we obtain in elimination reaction. So let's see, and this is my byproduct. So byproduct is nothing but the abstraction of the alkoxide, and we get a ethanol, and this is a displacement of the leaving group, we get a halide ion, and halide ion, it combines with the metal to form your salt. So let's see what is the steps involved in this E2 elimination. The attack of the ethoxide, that is any alkoxide, on beta hydrogen and its abstraction as a proton, that is the first step. This will leave 2 electrons of the CH bond. So there are the 2 electrons of the CH bond available for the formation of a new bond, and this is my new bond, that is I shown here with a partial bond between the carbon. As the new double bond is created, there has to be the leaving group, because otherwise the carbon valency will change. So there is a breakage of the carbon halogen bond, and then we get our ultimate alkene as the product. So E1 elimination. So about the E1 elimination we are going to discuss in our forthcoming video. So stay tuned. Thank you for your